Good morning, boys and girls. Mr. Giomini. We're going to model a couple problems from lesson 1-4, solving equations with multiplication and division. These problems are a little bit more involved than some of the ones we did today in class. It actually incorporates both the addition, the inverse property of addition and subtraction and multiplication and division. So it's a little bit more strenuous, but I definitely think you're up to the challenge. So take a look at the first one here. I'm just going to rewrite it down here. It says 5 times z minus 2 is equal to 13. Now, tendency for a lot of us is to divide this and get rid of this 5 first. But because this is the coefficient, I'm going to hold off on this. And it's almost kind of like reverse order of operations. I'm going to get rid of this subtraction first. I want to hold on to this coefficient for a little bit. So because I really can't combine the z's with this over here and stuff of that nature just yet, so I'm going to hold off on that, and I want to get rid of that 2. Well, to get rid of the 2, I do the inverse, or the opposite of subtracting 2, so I'll add 2. And recall, whatever I do to one side of the equation, and the equation is kind of separated by this equal sign, I must do to the other. It's a balance. So I'm left with the 5z. So 5z's are equal to, now this says to add 13 plus 2 gives me 15. Okay, some of you are probably jumping to the answer. I'm evaluating for, I want to evaluate for 1z, not 5z. So to get rid of the z, this says 5 times z. So I divide both sides by 5 now. That gets rid of the 5. Divide this by 5. I am left with z is equal to 3. If I want to check my answer, I can substitute back in up here and put the 3 here. And I go 5 times 3 is 15. 15 minus 2 equals 13, so that would be a check. So when I go to write my answer, I would say that z is equal to 3. Let's take a look at another one here. Let's go to x divided by 12 plus 3 is equal to 8. Okay. The quotient of x divided by 12 plus 3 is equal to 8. So let's see here. I'm going to leave this variable here by itself for a little bit. I want to focus in on this 3. I want to get rid of that 3 first. It has nothing to do with the variable right now. So I'm going to kind of simplify this equation by getting rid of the 3. Now it says to add 3. And remember, here's my equal sign. So whatever I do to one side, I must do to the other side. So I'll subtract 3 from both sides. Okay. I have not done with anything with my x divided by 12. So these cancel out. Bring that equal sign down. 8 minus 3 is 5. Okay, now this says x divided by 12. Well, instead of dividing by 12, I'm going to multiply by 12. But because this is in fraction form, I'm going to multiply by 12 over 1. These have the same, these cancel each other out, so I'm just left with x over here. Remember, whatever I do to one side, I must do the other, so I'm going to multiply this by 12 over 1. And really, boys and girls, when you have 5, it's the same as 5 over 1. So I just when I multiply fractions, 5 times 12 is 60. 60 over 1, which actually equals 60. Now let's check to see if this works. I'll substitute it back in. 60. So now this is 60. 60 divided by 12 is 5. 5 plus 3 equals 8. So yes, indeed, I now know that x equals 60. Okay, I'm going to erase some of these to give myself some room. Oops, I don't want to make any shapes. So let's get rid of this scribble here. Alright, and let's take a look at, let's rewrite this, 6y plus 3 is equal to 27. Alright, first step I want to do, I see that I have a coefficient here with the variable. I'll leave that to the last. To simplify this, I will get rid of the 3 first, so subtract 3 from both sides. That gives me 24. These cancel out. I'm left with 6 times y. Okay, now I want to evaluate for 1y, not 6 of them. So I'll divide both sides by 6, or I could say I'm multiplying by 6's reciprocal. which is 1/6. I will divide this side by 6. That gives me y is equal to 4. If I substitute 4 in, 6 times 4 is 24, plus 3 is 27. So I do know that y is equal to 4. I guess I'm having fun with changing colors here today. I do want to show you though real quick. Let's say that you made the mistake and you say, well, why can't I just divide both sides by 6? So let's do this first. Let's go 6y plus 3. I'm going to do the same equation. Is equal to 27. Now let's say that you wanted to start with dividing this. So you want to divide both sides by 6, or really multiplying by its reciprocal. Okay, so I'll do that to this side, and I'll do that to this side. Okay, so that leaves me with 3 is equal to, now this is actually 1/6y, I guess, so that gives me 27 over 6y. And well, now I need to evaluate for y again, so now do I multiply both sides by the reciprocal here, which is 6/27. So if I multiply this by 6/27, that gives me 18/27 is equal to y, I guess, if my math is right. And if I substitute that in here, I'm not going to get this 4. So that's why when you have a mix of coefficients and whole numbers, or numbers that are not connected to the variable, get rid of those numbers that are not directly linked to the variable first. If not, you get all kinds of mess here. Let's take a look one more at a story problem. It says here, on a trip to Indianapolis, Indiana to Houston, Texas, Mr. Sanchez averaged a speed of 63 miles per hour. The total distance of the trip was 1,071 miles. Write and solve an equation to determine how long it took Mr. Sanchez to drive from Indianapolis to Houston. This is the problem that's going to hurt us. When we have to write and solve an equation, we struggle. Now, I'm thinking many of you right now know what operation you would use to solve this. You would say, hey, you know what? I'm going to take 1,071 and divide it by 63, which is fine. But remember, if you look back at those equations we've been solving, when the equation is solved, you're actually using the inverse. So if we would use division to solve it, that must mean the equation must have multiplication, the opposite of division. So we know he was driving at a speed of 63 miles per hour. We know the total distance was 1,071 miles, but we want to determine how long it took him to make that trip. We want to know time. So I know that I could take his 63 miles per hour, times that by something, and get his total distance, which was 1,071 miles. Well, I don't know how long it took him, so I'm just going to call that h for hours. So now I want to solve or evaluate for h. I don't want to know what 63 h's are. I want to know what 1 h is. So I'm going to divide both sides by 63. Okay, now we might be prone to get our calculator out, but I'll do division old-fashioned way, like I did when I was in 6th grade. Okay, that gives me 1. That is 63. I have to subtract. That is 4. That gives me a 10. Well, 10 minus 6 is 4. I'll bring down the 1. Okay, 63 times what gives me 441? Or 6 times what gives me close to 44? Hey, you know what? 7 gets me real close. 7 times 3 is, well, let's do that over here. I'll do it on the side here. Let's go 63 times 7. 7 times 3 is 21. 42 plus 2, that's 44. Oh, look at that. It works out perfect. 441. Nothing left over. So I know that h equals 17, and in 17 hours. Now, boys and girls, on the quiz, you would get 1 point for writing this equation. You'd get another point for solving it. Notice on the equation, I am not having the variable all by itself, then the equal sign, then two numbers together. Notice it's a combination of number, coefficient, and variable on one side, equal sign, and then another number on the other side. Think about that. If you want a little extra credit, here's 3 problems or 4 problems. I will give you a total of 5 extra credit points if you can come in with those solutions. Use the previous videos or use the previous pages that I just used to help you out. Remember, you can always pause, rewind, and things of that nature. All right, take care.